All right, please confirm you can see my screen. I also brought in help with a calculator because these are some crazy calculations and there's no way we can do it without the help of our top cheetah. So I had to call the top cheetah just to make sure we are all together. All right. Please confirm you can hear and see the screen so that we can finish this long process. And as you guys have seen that this is not an easy task, there's a lot of things to consider, a lot of things to do, and at the end, everything must work fine, 100% fine. If it's not working, there's a problem. Okay, so I brought in the top cheetah to help me. I'm just gonna, I don't think I have, I don't have space at the bottom, but I wanted to quickly do everything together here so that we can see we will get the same answer. But let's do it step by step so that we are all on the same page. I'm just moving to the side because I will be putting the answers over here, right? We will have a matrix over here. Okay. So the first one is, I'm now going to punch everything in the calculator as it is. So we have -8 multiplied by, and we said it is -7, and we said it's over 48. All right, that's the first one, and I can press equals to. That will give me a 7/6. So I can write it in here. That's a 7/6 plus. The next one is a -2 multiplied by a 4 over, sorry, -2 times 4 over 48, and that I get a 1/6. Oh, sorry, I forgot the negative sign. Did I forget the negative sign? Yes. Did I? Minus 2 minus. Okay, something doesn't seem correct here. It looks like somewhere a minus sign is missing. So that is what I was saying, that minus sign is missing. This is negative, positive. It's became negative, negative, positive. Okay. I will just correct something over there, because here it's supposed to be okay, it's a minus sign. It's fine. Let's leave it like that. I think that is correct because I just saw now everything is still fine. It's not wrong. It's -1/6, and it's fine. The next part will be, let me do the bottom part, and I can shift. So the next part will be a 4 times bracket -7 over 48. That will give me a -7 over 12. So over here is -7 over 12 plus, then we do the next one. I'm now doing each one of this over here at the bottom. So some people say when you are done with the calculation, you can like scratch them out, what you have already done over on this side. Then it's easier to follow. So let me also just do that. The next one is a 7 multiplied by a 4 over 48, right? And then I get a 7 over 12. 7 over 12. And now we can move to the side. So those ones are there. Then we are over on this side. we have a -8 times -2 over 48. That gives me a 1/3. 1/3. And then we have a -2 times 8 over 48. And that gives me a minus, this is plus, -1/3. Then we have done, this part is done, this part is done. Just the final one at the bottom now. We have a 4 multiplied by a -2 over 48. That will give me a -1/6. I'll write it down, -1/6. And then the other part, the last part, which is a 7 multiplied by 8 over 48. And that gives me a 7 plus 7/6. And that is supposed to be closing it off. And yeah, you will notice a very interesting thing. You can further add this up on your calculator. I don't need to add them up because I can see already what is happening. So 7/6 plus minus, this plus minus will result in just a -1/6. This will equals to a 6/6, which is a 1. You can see 1/3 plus minus 1/3. This will be equals to a 0. You can see here -7/12 plus 7/12. This will be equals to 0 divided by 12, which is just equals to a 0. And -1/6 plus 7/6. This will be equals to a 1. So you can see that our final matrix is equals to a 1, 0, 0, 1, which is our ID, which is equals to the identity. So this is what we have been using in the beginning, and you can see the ID is the one here at the top that I showed you. It's what we got from multiplying our matrix over here, multiplied by its inverse, which gave us the ID. And you can see I followed the matrix multiplication step by step. And you can see that if you did not practice the exercises, activities that we put up, all of these things will look Greek to you. It will be like I'm talking a different language. And this is why I said that everything we are doing basically counts. We hoped you would make the most of it, seriously make the most of it as well. So let's open the floor for questions and tackle. Please ask your heart's content, or maybe we should have another example again, and then we can probably look at things. Is there questions? Is there should I do another example again? Or should I re-explain some parts that we did not look at or we missed before we continue? And please note, this is again not the end. This is not the end because we have just done the following. Okay, I will look at the chat just now. Okay, I will look at the chat just now. Let me just quickly go here. Yeah, I want to quickly show you. what we have done, so that you can see we have done this, we have done this, we have done this, we have done this. We've spoken about this. We spoke about the identity matrix use, okay, and calculate the determinant and inverse of a singular matrix. That is what we have done. So we still have this to do tomorrow, which is another problem, another difficult thing to explain. So please ask already in this part so that we can at least tackle everything out. So I see Jay says sir, is it not minus 8/48? So let's just quickly go back there. Let's go back. Can you just please elaborate where we have the minus so that we are all on the same boat or on the same place? Okay, let me just clear these other drawings. We don't need them. Okay, minus 8/48. So the only 8/48 that I have is this one over here. Let me just draw it quickly up. It's this one over here. This is the only 8/48 I have. All right, and where I am multiplying them, this is the only places here that I am multiplying them by, and here that I'm multiplying them by. Okay, so I don't see where the minus 48 comes from, because also the minus 48 makes a positive 48, and this one over here is a positive 48. Okay, I see you say you understand. All right. So whenever, remember that the rule I wrote down in the class, wherever you have a minus and a minus, this is a positive, a minus and a positive, this is a negative, a positive and a negative, this is a negative and positive, this is positive. So this was those things I always used to write down on top of the board, like it's a key. I used to call it a key. Like remember this, and you will see that I use brackets a lot to keep my negative numbers in a bracket so that I don't mess up one of these things over here. All right. So you can see that when you are looking at it, just by looking at these things, there's no way you will see that it will end up to a 1 and a 0 and a 0 and a 1. There's no way. Because if you just try to look at it and like, no, it must give me a 56 here so that it can be a 1. No, we are adding it with something else. And that is the problem, that our brains are only focused on the first part. We don't consider that we are adding it to the second part. Is there any other question, or should I do another example again from you guys? Any questions or another example? Or do you understand? I can just give you the activity to try. You can unmute your mics and let us discuss these things. If it's not clear again, then we can also discuss what is not clear. I'm free today because tomorrow I really want to look at the simultaneous equations and see if we can at least understand everything there. Okay, so Loida is in for another example. So let's just prepare that quickly. Okay, just give me a few moments. I just want to get to a blank page so that we can do another example. Okay. For Loida's sake, Loida, please give us a matrix that we can use for another example. Then we will call it a day. And for this example, I will be again explaining it as if we were writing it in the examination and not explaining it as a lesson, because explaining it as a lesson will take forever and we will miss certain things. So let's get some numbers again for a new matrix. And this time, let's call this matrix Z. Because we used X already. So matrix Z has elements. Please give us numbers that we can put into the matrix Z, and preferably not textbook. If you have your textbook, you can probably give one matrix from the textbook as well, if you have it. If not, it's also fine. Okay, I have a 10 from J. Yeah, we can use that 10. Good numbers. 10. Any other number? We need 4 numbers. We are only doing 2 by 2 matrices, so it's fine. I have a minus 11, so minus 11. I have a 6, one more number, and a 3. All right. Okay, so these are the numbers that we have: 10, minus 11, 6, and 3. So when we get the matrix like this, we are asked again to find the inverse. So I will write it down: inverse. Okay, question mark. So first, before we even look at the inverse, we need to know what is our determinant, and we need to know what is our adjoint. Okay, so I will do this too. I'm answering it as if this was an exam question. This is normally your working space. So determinant, adjoint, those are the 2 things you must always calculate first before we calculate the inverse. So determinant is the cross multiplication and subtraction. So I have the determinant will be a 10 multiplied by the 3. This I will put in a bracket, minus the 6 multiplied by the minus 11. Please note, for the determinant here, it doesn't matter whether the minus 11 is first and then the 6, you will still get the same answer. So normally we can do this in a straight line because it's fairly simple. So I'll have 30 minus 66. And remember, wherever I have this like minus things, I always like to put a bracket to show me that this will change to a plus. So it'll be 30 plus 66, which will give me a 96. That is what I have. Then for the adjoint, adjoint is going to be a matrix always. So for the adjoint, we will flip the 10 and the 3. So the 3 will go to the top, the 10 will go to the bottom corner, and then we will multiply the minus 11 and the 6 by -1. So minus 11 is already having a minus, it will change to a positive. 6 is positive, it will change to a negative. Okay, that is basically it that you need to do for the first part. And now, once we have the first part, then we now say that the inverse of z, which is z to the power of -1, is therefore equals to 1 over the determinant, which is 96, right? Multiplied by, we can use multiplication here because there's no x, multiplied by the adjoint, which is 3, 11, minus 6, and 10. And obviously here I can even continue in a straight line. It will be easy, but let us just work down, and then I will do the testing over on the other side. Then it's easier. So we know that this will be equals to, just put everything here. If it's 1 over this, then you just know that the number will go to the top, right? So I will make it a little bit big because it's now fractions that we are dealing with. So it will be 3 over 96. And then the other one will be 11 over 96. Then I will have minus 6 over 96. And then I will have a 10 over 96. So that is your inverse. So this is how we get to the inverse. So we will normally give a mark there for the determinant. It's easy. A mark for the adjoint, a mark for the formula, and then we will give either 2 marks here. So at most, if this was find the inverse, you would either get 5 to 4 marks, okay, 5 or 4, 4 to 5 marks for calculating the inverse. But if we ask you to calculate the inverse and then test or prove that it is the inverse, okay, then you will have to now, we'll add more marks to the other side as well. So for our testing or our proving, we notice that we will say Z, all right, the inverse matrix Z multiplied by its inverse, Z -1 must give us a ID. ID is our identity matrix, and I will just put it here so that you can see this is a 0, all right? This is always going to be the ID, okay? So that is what we need to prove. So first I will write down Z. Whether you say the inverse is first or Z is first, it doesn't matter. You will still get the same. You must get an ID, okay? So this is unique. It doesn't matter which one is first here. So, but I just like to put Z first. So Z is 10 minus 11, 6, and 3. That is what we have. And we are going to multiply by its inverse, which is 3/96 minus 6/96, 11/96, and 10/96. There's only one negative number in there. Right, so that is the first part. And then obviously from here, if we have to do it like this, you will end up with a big multiplication matrix. And then we do what we said we are supposed to do, which is our rows by column. Okay, and then again a row by the other column, and then we repeat it. Okay, so let's get into the writing. I'm going to start using blue so that we can see. So the first row, I have a 10, right? I have a 10, and I'm multiplying it by the first column, which will be a 3/96, right? Plus the second element in the first row, which is the -11, multiplied by the second element in the first column, which is -6/96. And that is what I have. And if you remember the rules that I told you before, we will also have a bracket here, plus a bracket here, and a bracket. I don't know if I have space for that other side. So you will notice that I said that the quick way to do this is once you have your first one, then I know that in this bracket here, there must be a 10 multiplied by something. In this bracket, there must be a -11 multiplied by something, okay? So, and then you will notice that here we use the first column. So in here, it must be the second column, first element, second column, first element. So here it will be 11/96, and here it will be 10/96. So this is multiplication. So this is how I know. And then over here, I will basically also have the same number of brackets to do the calculations. And I already know what will be the things inside that brackets. Since here we said that the first row already is finished with its numbers, here we will have a 3/96. Here we will have a -6/96. Here we will have an 11/96. And here we will have a 10/96. Okay. And this is multiplied. So all I need now is the second row's element. So that is a 6, and the other one is a 3 or 8. It's a 3. And then I have a 6, and then I have a 3. See? So this part is easy again. If you know that that your elements from the row will always be in that same row. The elements from the column will always be in that same column. Okay. column, 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 column. Okay, that's the things of the columns that we are taking. And then we add them up. That is an important step of the adding up part that we have. So when you reach this part over here, what you need to do is, I don't know why it's showing in front. Okay, I have to take a screenshot again. It's new. Okay, so I make use of screenshots because I don't want the thing to be in front of the element. Okay, there's a slight problem because of the screenshot. Just bear with me a little bit. Okay, please confirm you can still see my screen. Can you guys still see the screen? There was a flickering part, so I have no idea if it did what it's supposed to do. Okay. So if you can see the screen, then it's fine. All right. Okay, so this is basically just what we have. So I'm using this to make the board a little bit bigger and expand the brackets. And I think now our calculator should work fine. Okay, our calculator is having a problem. Okay, just quickly reset the calculator. Okay. Right. So I just had to bring the calculator in so that at least we can do the calculations together. Okay, so most of the time, some of these things are fairly easy. I'm going to use a black pen here since I know that this will be 30 over 96. But let's just make sure we don't mess up anything. So it will be 10 times 3 over 96. And that will give me 5 over 16. So the answer here, they say is 5 over 16 plus the other part is minus 11 multiplied by 6 over 96. And then I get, oh, sorry, it's minus 96. So that is a minus 6 over 96. So I get a 11 over 16. That is for the first part. For the second part, I will get a 10 multiplied by 11 over 96. And that gives me 55 over 48. And then the other side, I have minus 11 multiplied by 10 over 96. And I get plus minus 55 over 48. And the next one is a 6 multiplied by 3 over 96. That will give me a 3 over 16. And the other one is a 3 multiplied by minus 6 over 96. That gives me a plus minus 3 over 16. Then the next one is a 6 multiplied by 11 over 96. That will give me 11 over 16. And the last part is a 3 multiplied by 10 over 96. And that gives me plus 5 over 16. Okay, so all of these complicated things, we have simplified them out. And please note that the black pen that I did, you have to make another another step inside there, but this is also fine if you make space enough to write it in you, and you can show the calculations there, it's fine. So I can see that 5 plus 11 is 16. 16 divided by 16 is 1. All right. 55 over 48 plus minus is just equals to minus. So 55 minus 55 is 0. So that would give me a 0. 3 over 16 plus minus 3 over 16. 3 minus 3 is 0. So that would give me a 0. And 11 plus 5 is 16. So 16 divided by 16 is a 1. And here you can see we got our ID again. So again, we got our ID by proving, and you can see now the ID is again here on top, which is the 1001. Okay, and here we get the same thing again, just by simplifying it out. So I hope that was clear. Again, so this was the examples you guys gave me, and this is normally what we also do to the examinations. We just make random numbers and then we ask you to do it. Okay, can you do it? Do it. So that is it for inverse of a matrix. Let me see. Let me just try and copy this, and I can paste it in our lessons. Then it will be easier. Easier later on once somebody asks to share. Is there any other more questions regarding this, or is it okay? We don't have a lot of time left anymore, but I can always see if I can accommodate a question or two for the rest. Any questions, or was that clear to everybody? Okay. Right. So thank you, guys. You will notice again that I will be posting an activity for us to do regarding inverses as well, adjoint of a matrix, inverse of a matrix, and so forth. So that we can, let me just show you the thing. We will also be sharing this with you. This is just basically talking about what we need to do as well. And then we have questions regarding this. Question 1, find the two possible values which A has no inverse. So you can see now how we change the question. So if we are asked a question like this, which A has no inverse, then you should know that we just talk about the determinant. So make the determinant equal to 0. That's basically what the question is saying. All right. And then show that the root of 2 k equals square root of 2a itself is a self-inverse. The inverse is the same as the original matrix. We've talked about that, where it's minus a inverse. And then we have extra examples over here. We have, this is normally how the exams also look like. We just give you a matrix A, matrix B. We ask you to find the inverse of matrix A, find the inverse of matrix B, and then we find the inverse of BA. Now you will see that if you did not do your multiplication, all right, matrix multiplication, you will not know what this means. This is Greek again. it becomes too difficult and too Greek for anybody to understand. So here it means you must multiply matrix B with matrix A. So B is the one on the left and A will be the one on the right. You multiply them, you get the answer, which is called BA, and that answer, you find the matrix. This question over here is normally like the, what do we call it, 6-8 marks question, 6 to 8 mark question, because you first have to multiply, then you have to go and find the matrix there. So it will be the 4 plus the other 2 or the other 4, and then you get it. So you can get a question just like this. Let's say the first one is 4, 4, 8, 16 marks. Game over. So that's one example. This one is easy. And then we have an extra worksheet that we would like you to complete again. This one is just looking at straightforward. For each of the following, state an inverse if it exists, means find the inverse if it exists. So you have to do that. Again, here, find the inverse of the matrices. Again, it's just different matrices that we have. Critical thinking questions before we end. Give an example of a 2x2 matrix with no inverse. Maybe one of them here has no inverse. You could give that as an example. Give an example of a matrix which is its own inverse. That is where the inverse of the matrix is the matrix itself. Interesting question. I don't want to give this answer, but this will open your eyes. If you solve number 18, then the rest of the other things will be like, oh, I see. Right. Okay, fine. Right. So those are the 2 ones. You will see that all of the ones here are just 2x2. We are not doing 3x3 here. Next year, you will do 3x3. And I pray for the teacher who has taught you. Good luck. So tomorrow we'll be doing simultaneous equations. And that is another problem to explain. And tomorrow we will be starting normal time. That will be 2 o'clock, not late like we did today. Is there anything else from you guys? Otherwise, we can call it a day. Anything else from you guys? I will post these things on Google Classroom so that you can get it as well. Anything else from you guys? All right.
No, sir.
Right. So if there's nothing from you guys, then have a great day ahead, and please attempt the activities. See where you are struggling, so that when I ask, can I explain anything, then at least you can tell me, so please explain this again, and then we can take it from there. Right. Thank you guys for joining. We will see each other tomorrow.